Hi everybody, welcome to day 2. We're actually going to start out with a little bit of a warm-up. So you can see I have 2 problems here. So I want you to take a look at this first problem. I'm going to give you a few minutes. So pause the video, pause the video, and see if you can come up with an equation. And if you feel confident on your equation, go ahead and solve it. And if you're not fully confident on your equation, just unpause the video and then pause again to solve it. All right, so you can see I've already written an equation. Now I wrote the long version of this equation. So if you look at this picture, you can see these 4 angles, O, N, L, and K, all have the same congruent mark in them, which means they are all 9x plus 30. And angle J and angle M both have the same congruent mark in them, which means they're both 2x. So the long way to do this is to literally write out each angle measurement. So there are 6 angles, so I'm adding together 6 things, 1, 2, 3, 4, 5, 6. And then I set it equal to 720 because it's a hexagon, which means there are 4 triangles that will fit inside it. So this 720, if you don't have that table in front of you or you don't have it memorized, it's just the number of triangles, 4 triangles times 180, so that's 720. Now a lot shorter and faster way to write this would be 2 times 2x, because we had 2x values, and then 4 times 9x plus 30, because we had 4 of those angles that were 9x plus 30. But either way, it's still going to equal 720. So if we go ahead and simplify this, we're going to have 4x plus 36x plus 120 equals 720. And now we're going to solve that equation. So 40x plus 120 equals 720. Subtract 120 from both sides. Oops, 40x, not 4x. 40x equals 600. And divide both sides by 40, and x should equal 15. So we always want to go back once we find something and make sure in our directions we've finished the problem. So we've actually only done one part of this. We've found x. So then to find angle K, that's got the same mark in it as N. So then for angle K, I'm kind of out of room here, so I'm going to go up here. So the measure of angle K is going to be 9 times 15 plus 30. And then for the measure of angle M, that's got the same congruent mark as J, so that's the measure of angle M is going to be 2 times 15. So the measure of angle K is going to be 165 degrees, and the measure of angle M is going to be 30 degrees. So now we found all 3 parts. All right, let's take a look at the second one. So it says if the sum of the interior angles is 1260, how many angles does the polygon have? So take a minute to think about it before you just watch the video. See if you can come up with any strategies or any ideas. So you may have a different strategy than I show you. That's okay. If your strategy works, we'll end up with the same number. So one thing you might have done is actually gone back to your notes from the other day and just looked to see that 1260 degrees is when there are 7 triangles, so there's 9 sides. So if you have your notes handy, please feel free to use them. That's what they're there for. But if you didn't have that, what could we do? Well, if you remember yesterday, we talked about how to find the sum of the angles by doing the number of triangles times 180 degrees, because every triangle has 180 degrees in it. So if we know the sum is 1260, and then that would be our triangles times 180, then we can divide both sides by 180. So that will give us 7 triangles. And then if you remember, the number of triangles is not the same as the number of sides, and we're looking for the number of angles. The number of sides and the number of angles will be the same. 6 sides, 6 angles, 5 sides, 5 angles. So if this is the number of triangles, do you remember how we figure out the number of sides it has? So the number of triangles is equal to n minus 2. So that's our number of triangles. So that means we're going to have to add 2 to this. So the number of angles, which is equal to the number of sides, will be 9, just like it said on our table. All right, so that's just to review a little bit of what we talked about yesterday and kind of like pushing ourselves a little bit on this. we're going to talk a little bit more. We're going to dive a little bit further into angles and sides of polygons today. Now, if you'll notice here, for this first part, we're going to be finding the interior angle measures of regular polygons. So we have to remember some vocab from yesterday. So what does regular mean? Squares are regular. Equilateral triangles are regular. So do you remember what makes a square a square? It's going to have 4 equal sides, and all of the angles are equal to 90 degrees. In an equilateral triangle, equilateral means equal sides. Equilateral triangles are also equiangular. So that means regular polygons are going to have equal sides and equal angles. So that means all of these sides are the same length and all of these angles are the same size. So that means if we can find all, like the sum, we can find out how many degrees are in the whole thing, then since all of these angles are the same, we can divide them evenly and it'll tell us how much is in each individual angle. So that's going to be our goal here. So let's look at example 1. This is a regular polygon because it told us it's going to be regular. You don't want to assume a shape is regular. You either need to be told it's regular, like we are here, or it needs to be marked in your picture. And in order for it to be regular, it can't just be sides, it has to also be angles. It can't just be angles, it has to also be sides. So we know that this is regular, and if we count the sides, 1, 2, 3, 4, 5, this is a pentagon because it has 5 sides. So in order to find out how many degrees is in each angle, first we need to know the sum. So the sum, if you remember from up here, our sum is the number of triangles times 180. Or if you have that chart handy, you can use that chart. So the sum is going to be the number of triangles times 180. So in a pentagon, we can form 3 triangles. So we're going to have 3 times 180. So then our sum of the interior is going to be 540 degrees. That's our sum. That's all 5 angles added together. But we don't want all the angles added together. We want one specific angle. So I want to know how big each one of these angles are. Well, since all of the angles are the same size because it's regular, we can divide that 540 evenly into 5 pieces, and that's going to give us 108. So one interior angle, so not all of them together, just the one this time, is 108 degrees. All right, so let's check out a shape that I can't draw. So I can't visualize this one very well because I can't draw a 20-sided shape, but I do know that it has 20 sides. So if we use the same process we did over here, the first thing we did was find the sum of the interior. So how did we do that? We did the number of triangles times 180. So how many triangles could we get into a 20gon? The number of triangles is always n minus 2. So n stands for your number of sides. So sum is going to be triangles times 180, but triangles is really n minus 2. So that's the number of sides. So in this case, we're going to have 20 minus 2. So there's going to be 18 triangles. And we're going to multiply that by 180. I imagine that's probably a pretty good size number. So 18 times 180 is 3,240 degrees. Now that's the sum. That's if we were to add every single one of those angles together. So 20 sides means it has 20 angles. Now we want one interior angle though. So one interior angle. So we want to divide this 3,240 evenly into not 18 pieces because that's how many triangles, but we're going to actually divide it all the way into 20 pieces because it has 20 sides, which means it has 20 angles. So we just take that 3,240 and divide by 20, and that's going to make each angle equal to 162 degrees. Okay, so now we're going to work with angles in a little different capacity. So this time we're going to be finding the interior angle measures, but we're going to be given the sum of the interior angles. Now we're still working with regular polygons here, which means all of the angles are going to be the same size. So this is actually kind of like this one up here. We're going to use this to help us out. So we know the sum of the interior angles is 2,880 degrees. So that means when we add all of the angles together, it's going to equal 2,880 degrees. So if we can then find how many angles there are, then we can do like we did here, where we did the sum of the interior divided by the number of angles. So we're going to use part of what we did here in the warm-up, part of what we did here in example 1 and example 2, and we're going to put that all together to do example 3 and 4. So if the sum of the interior angles is 2,880, the first thing we need to do is we need to find the number of sides, which is also the number of angles. So how did we do that before? We said the sum of the interior angles was going to be the number of triangles times 180. So we're going to take what we know, 2,880, equal to the number of triangles, we don't know that yet, times 180. So we're going to divide both sides by 180. And that's going to be 16. Now 16 is the number of triangles, so now we need to find the number of sides. So if you remember from up here, there's always 2 less triangles than there are sides. So the number of triangles is really n minus 2. So 16 is really the n minus 2 bit from that equation from the other day. So we're going to add 2, and the number of sides and the number of angles is 18. So this is 18 sides, 18 angles. So now that we know the number of angles, we're going to, and it's regular, all of the angles should have the same amount, we're going to divide 2,880 evenly 18 times. So that's going to give us 160 degrees. So one interior angle is going to equal 160 degrees. All right, let's see if we can do that again here. If you're feeling pretty good about it, go ahead and pause the video and see if you can tackle this on your own first, but if you need a little bit help, feel free to play along. So first thing we're going to do is the same thing we did over here. We're going to find the number of triangles. So we have 1,620 equal to the number of triangles times 180. So we're going to divide 1,620 by 180, and that's going to give us the number of triangles, which is 9. So remember, there are 2 less triangles than sides. So that means there's 2 more sides than triangles. So the number of sides is going to equal 11. Almost done. So now we're going to take this 1660 and divide it by 11 evenly and see how many degrees are in each angle. So 1620 divided by 11. And this is 147.27 repeating. So I'm just going to go ahead and round that. One interior angle is 147.3 degrees. All right, so we know how to find an interior angle if we know the number of sides. We know how to find an interior angle if we know the sum. So now we're going to move to exterior angles. So interior angles are all of the angles on the inside of your shape, right? All these angles on the inside of our shape. Our exterior angles are created if we extend the side, then this angle right here is an exterior angle. If we extend this side, this angle right here is an exterior angle. So in this pentagon that has 5 sides and 5 interior angles, there are 1, 2, 3, 4, 5 exterior angles. Now again, we're still dealing with regular polygons. So that means all of the angles are the same size. Now, I'm going to throw some vocab at you from first semester. Do you see that the interior angle, this is my interior angle, and my exterior angle are next to each other, they're adjacent, and together they make 180 degrees. So that means the interior angle and the exterior angle are a linear pair. You remember that vocab from before? So your interior angle and your exterior angle will always add to 180 degrees. So if this is a regular pentagon, how many degrees is the sum of all of those exterior angles? Well, let's see if we can figure that out. I believe over here in example 1, we had a regular pentagon, and we actually have already done all of the work. We know that the interior angle is 108 degrees. All right, so if this angle is 108 degrees, and all of these are the same size, wouldn't all of these be 108s? And if we did 108 times 5, we would get that 540. So if this is 108, then how big is the exterior angle? Well, if the interior plus the exterior is 180, then we can figure that out by doing 180 minus what we know, which is 72. So the exterior angle is 72 degrees. Cool. So then what's the sum? Well, we have 5 exterior angles. If all the interior angles are congruent, that means all the exterior angles are going to be congruent. So our sum is just going to be 72 times 5, because they're all equal to each other. So I'm going to write sum, and then I'm going to put an ext at the bottom, because now we need to distinguish between interior and exterior. 360 degrees. Cool. All right, so that's our pentagon. Its sum is 360. All right, let's look at our hexagon. I know this is a hexagon because it has 6 sides. Okay, I don't think we've done hexagon yet, so we don't automatically know the interior angles, so we're going to go ahead and find those really quick. So let's see, hexagon has 6 sides, which means it's going to have 4 triangles. So 4 times 180. Or you can get your chart out from the other day. So hexagon has 720 degrees on the interior. So 720. So the sum of the interior is 720. So this is the sum. I'm going to put an int at the bottom for interior. But we want to know each interior angle. So we're going to divide that by 6. So one interior angle is 120 degrees. Okay, so just like in the pentagon, our exterior angle is going to be created by extending all of these sides. So if our interior angles are all 120, then our exterior angles are all, that would be 180 minus 120, 60 degrees. Okay, so every exterior angle is 60. Well, we have 6 of those, so the sum of our exterior is going to be 60 times 6, which is equal to, oh, that's interesting, 360 degrees again. So I wonder if that's a coincidence. Let's try another shape. Let's just do a quadrilateral. Let's make it super easy. Let's do a square. All right, so in a square, we know that all of these are 90, right? Okay, so if I extend to find my exteriors, this angle has to be 90. 180 minus 90. This would have to be 90. This one is 90. This one is 90. So that would be 4 times 90, which equals 360. Interesting. So whenever you have a regular shape, so the sum of the exterior for all regular shapes is always 360 degrees. So no matter how many sides it has, always 360 when you're talking about the exterior. Now the interior angle measurements, those change, but the exterior sum is always 360. All right, so how can that help us going forward? Well, one thing, we were able to find this exterior angle by using the linear pair, right? So if we can ever find an interior angle, we can always use that to find the exterior. Or vice versa, if we know the exterior, we can use that to find the interior. So we have a couple things that we can do with this. So let's look at example 5. We're going to find the number of sides, and I'm going to give you an interior angle. So our interior angle is 135. So I don't know how many sides this has. I know it's going to look something maybe like this. Oh, that's terrible. Let's try that again. A little straighter that time. So this angle right here we know is 135. Now, we're still dealing with regular, which means this angle is 135 and that angle is 135, and however many angles there are, they're all going to be 135. So how do we find the number of sides? How do we know how many sides this has? Well, what do we know? From up here, we know the interior and the exterior are equal to 180. So if the interior is 135, then this would be 180 minus 135. So our exterior angle would be 45, okay? All right. How does that help us? Well, we do know the sum, no matter how many angles, no matter how many sides it has, is always going to be 360. So wouldn't every angle times however many exterior angles there are have to equal 360? Oh, I wrote that down. You couldn't see it. So 45 degrees is how big our exterior angle is. N is how many angles or sides it's going to have. And if the sum is always 360, then this has to equal 360. So if we divide both sides by 45, then we're going to have, let's see, 360 divided by 45 means this would have to have 8 sides. That makes it an octagon. All right. That one sometimes can be a little tricky to understand, so let's try one more. So this time our interior angle is 172.5. So a little bit bigger this time, right? So the bigger the angle, the more sides it's going to have. Fun fact. So this is 172.5. So how do we find the exterior angle? So that's going to be 180 minus 172.5. So 180 minus 172.5. That means our exterior angle is tiny. It's only 7.5 degrees. Okay, all of the exterior angles, no matter how many there are, they have to add up to 360. So if I know I have 7.5 degrees, but I don't know how many times I need to multiply that, I can find it by setting it equal to 360. So divide both sides by 7.5, and n has to equal 48 sides. So what's its name? There is no fancy name. It's just called a 48gon. All right, here is your homework for tonight. I will post that up there on Canvas. It's already up there. If you have any questions, please ask. Please reach out. Otherwise, have a fantastic day.